Hello, and welcome to 5-Minute Math. Today we are looking at the geometric concept of the midpoint formula, specifically how we can use it to prove some geometric ideas, and we will do it in 5 minutes or less. So, in geometry, we learned that the diagonals of a parallelogram bisect each other. That means they cut them into equal segments. But how do we know for sure? Well, we can use the midpoint formula. So we have rectangle ABCD here, and we already have drawn the diagonals DB and CA, and it looks like they meet in the middle at point E. But how do we know that those line segments actually are equal to each other? CE and EA, are those two line segments congruent? What about DE and EB? Are those two line segments congruent? Because if those line segments are congruent, then we can say they bisect each other. Well, we can use the midpoint formula to find where CA, the midpoint is, and then DB, where the midpoint is. And if they share the same midpoint, because it's the midpoint, by definition, the midpoint cuts a line into two equal segments. So let's find the midpoint of DB. All right, and then we'll know that wherever that midpoint is, the segments on either side are going to be congruent. All right, so I'm going to take the x values, and so let's take -9, and I'm going to add that to 3. Let's take the y values. I'm going to take -3, add that to 7, cut that in half, and so that's going to end up being -6/2, and then that's going to be 4/2. So that ends up being x of -3, y of 2. All right, so that is right there in E. So I know that E is the midpoint of DB, and so line segment DE, right? So I can say line segment DE is congruent to line segment EB. Now, let's see if CA has the same midpoint. And so CA, I'm going to take my x values, -9 plus 3. That should look familiar. Now, it's going to be 7 plus -3. So it's kind of like what we did on this top value, but the signs just switch between the 7 and the 3. But it's going to end up being the same thing. -6/2, +4/2. So I've got the same midpoint, -3/2. So now I know that CE is congruent to EA. And since they both meet at the exact same point, -3/2, we can say that diagonals of a parallelogram bisect each other. Sometimes we can use the midpoint formula to help us draw lines. So the median of a triangle is a line that connects a vertex to the opposite midpoint and bisects that opposite side. So let's say I want to draw a median from point Z on this triangle over here to this opposite side somewhere. How do I do it exactly so that I know that it's going to bisect the opposite side? Well, it's going to connect with line segment XY. So I want to find the midpoint of line segment XY. So let's take my X values. I've got 4 plus 7. Cut that in half. And then I've got a 6 plus for my Y values, and then a -5. So really it's a 6 minus 5 is what it's going to look like. So that's going to end up being 11 halves over 1/2. And if I want to, I can visualize that as decimals, right? X value of 5.5, and then a y value of 0.5. So then what I would do is I would draw a line, and it would go from here, and now I would need to find that spot. So 5.5 and 0.5 looks like it's going to go right around there. So if I were to connect those two, it would look something like this. Straight line going from Z, and I call it point M. And so we know that ZM, right, is the median. And so by definition, that median is at the midpoint. And so I can say that line segment XM is going to be congruent to line segment MY because that median is a bisector.